Right on time.
Oh, thanks for joining us. You're on mute at the moment.
Yeah, can you hear me?
We can hear you.
Perfect.
Loud and
Awesome. Yeah,
clear.
the dog's in the room today, so I'm gonna try to mute myself a bunch because they just breathe so loud, you know. Um,
Give him a mic.
no, it's two golden retrievers, and so they're just like, it's not good.
Nice.
Right
Very
on.
noisy.
All right. Well, let's get started here. It's just past 1, so we'll get the ball rolling. Welcome everyone for joining us. Thank you for joining us on this Friday afternoon. I know that's a lot to ask in some cases, but thank you. We're grateful for that. We appreciate it. I'm joined today with my colleagues, Adam Temple, CEO and co-founder of Evolved, and Murphy Murry, who truly needs no introduction, one of the brightest minds in our space and expert in our field, and leading the charge on enforcing ASTM standards for use of hydrocarbons in cannabis extraction. Today, we're diving into one of the most important and often overlooked topics in extraction, and that's solvent purity and BTEX contamination. There's been some growing concerns around benzene contamination in solvent that can, in some cases, accumulate over time and potentially end up in the final product. Our goal today is to help educate the community on why this is important, what you can do to protect your operation, and how to implement proactive risk mitigation protocols, as well as corrective measures. We'll also open the floor to questions throughout the webinar. Please feel free at any time to ask any questions. There is a comment box and a question mark box at the top right corner of your screen. Please refrain from using the comment box and put your questions in the question mark box. And we will do our
Let's
best
kick it
to
off
answer
with
them.
that, actually. Yeah,
Yeah.
let's see, like, if you guys could share in the question segment just where you're tuning in from. We got 38 people, still probably a few more to roll in, but I'd like to see kind of where people are tuning in from today.
Mm-hmm.
Guys. All right, Missouri, Colorado, Victoria, Toronto,
Nice.
Maryland, Ontario, Washington. Right on. Yeah, I saw a few from Ohio, and a few from Arizona as well. And I
Colorado,
know
yeah,
Murphy, you're
Oklahoma.
tuning in from Colorado, right?
Yep, I'm in Denver.
Cool. So let's dive into the kind of what we're going to be covering today. I'm Adam Temple. I'm CEO of Evolved Extraction Solutions. Been in the business for about 9 years now, so we've kind of seen it all, and we've had a lot of time to put quality measures in place, and we're really happy with the ASTM team for recently releasing the new standards. It really helps everybody get clear on how to actually ensure that everyone's on the same page and everyone's following something that's standardized. That's something that Murphy played a big role in, and now it's time to educate the community. So that's really why we're hosting the webinar. It's not really about enforcement. It's really just about education, getting everybody on the same page and making sure that there's broad awareness. One of the things that motivated me to start this webinar actually is talking to a few quality people, particularly in the Canadian extraction market, and realizing that there was just a broad unawareness of what benzene was and the fact that it could potentially contaminate butane, and actually does regularly contaminate butane that's used in cannabis extraction. The fact that awareness was really missing was a huge red flag for me, and really wanted to make sure that we're at least getting everybody on the same page so that everyone's aware of what the risks are, and then we can start to talk about how to mitigate them as a community, as an industry. And that's really what the STM committee set out to do. Murphy, if you want to kind of share a little bit before we jump in about what you guys were up to, that would be great.
Yeah, for sure. Huge credit goes out to the people who've been in it from day one with the D37 ASTM committee. It's been around for like almost a decade now. And gas purity was something that was brought up very early on in, very early discussions as the ASTM started approaching where we needed standardization and where we could, productively agree. We thought this would be a low-hanging fruit. We thought everyone would probably be pretty down with just like super high purity solvents for their cannabis use. And it turns out that they were, until we identified which contaminants we wanted to control for. And this is where it gets very murky. And so the ASTM committee actually has been trying to pass literally any standard, in relation to gas purity for years. And it just kind of kept coming to a head where there was no consensus and it kind of fell apart. So this year is exciting because we published a standard, which, I'm saying that with a lot of enthusiasm. Hopefully you guys can feel it. Like, it is hard to get a lot of people who are volunteering from the industry to agree, even when we do all kind of agree on the idea that we should be using pure gases. And the issues really came from how to quantify the contaminants and what the allowable quantities should be. And a lot of this came from, like Adam, you mentioned, just kind of unawareness. The people who manufacture the gas are not the same as the people who distribute the gas to us, and none of us are the same as each other. So the contextual knowledge that the supply chain has all the way back to the source is extremely limited, and it's not standard in any way. So everyone's bringing kind of their own fresh take on how they do their business to the standardization process. And what's unfortunate is that regulation tends to move faster than innovation. And so, a lot of people approach this as a really limiting standard when they're coming from the gas supply side, because they're saying no other product that they sell is regulated in this way in terms of butane and propane. These are industrial gases, no matter what it says on your invoice. And so there's not a standard coming from oil and gas. This is something we're imposing on ourselves. And so what we were able to get everyone to agree on is really some limits for the BTEX that everyone could test for. And that has been a hugely limiting factor, is that all of these cannabis labs have been testing for BTEX in the final product, which is a very, large amount of benzene or toluene or whatever we're looking for, compared to what might be present at a parts per million or parts per billion level in the gas. And it starts to become very relevant whether we're testing for the vapor from the liquids. So this has been a huge undertaking for what might sound like a very simple sentence stating that we want 99.5% pure gas with less than whole numbers worth of benzene in it. But it took a lot of work to get that simple sentence agreed on by everyone, and it's officially published, which means that now there is a description of processed gas that is an industry term that can be measured based on a testing method that's also cited in that standard. And so now, whether you want to call it medical butane or insurance butane or extraction butane or ultra high purity butane or specialty butane, it doesn't matter. You can see if it conforms with this ASTM standard and check the paperwork to match. So this isn't a big change necessarily in anything that's happening inside these cylinders, but what it is a huge step forward towards standardization, and that's going to lead to better accountability, which is what we're really looking for, is the tools to determine what is good and what is bad that would be the same for everyone, so that we can actually be good consumers of the gas suppliers that we're purchasing from, so that we can be good producers when we're making product for everyone else, and also so we can eliminate this as one of many potential sources for benzene to end up in your product. So, gas is just one. Benzene's a big problem. Whether or not gas is the culprit is the only one we're going to try to solve today.
Yeah, let's keep the scope at that. And I think the scope, especially now, like now that that standard is in place, um, it's really up to now the producers to adopt that standard and to like hold the actual production supply chain accountable to it. And that's really, I think, where this, I think that's the next step. And that's really what we're here to do is we're here to like, especially quality teams, those quality teams are really accountable for this. So let's like educate quality teams. Let's put the systems in place at the producer levels to ensure that we're, keeping the actual entire supply chain all the way to the consumer reliably safe. So that's what the webinar is about. We're going to cover, like, first of all, like, what is BTEX? What is benzene? A lot of people I've talked to weren't even aware of what it is. So let's start there. Real world stories. There's a few gas contamination stories that we can share just to kind of bring it home a little bit. And then how to actually spot the difference between kind of this more conforming standardized supply chain versus maybe gas that's non-conforming, and how you can prevent yourself from getting confused or getting them mixed up. And then how contamination happens and builds up, and how we can actually enforce or put in place hazard control plans to prevent it, and working with quality assurance personnel to kind of put those systems in place at the production level through education, consulting, etc. So first of all, what is benzene? Benzene is it's a carcinogen. It's a it's got toxicity for organs and potentially neurotoxic as well. And right now, one of the things that really surprised me was that Health Canada and a lot of states aren't even requiring the end product is being tested for this. So what that tells me is if the quality people aren't aware that benzene is even a hazard and it's not required in testing, then there's a pretty big chance that it just slips all the way through the supply chain right to the consumer, and nobody even finds out about it until some of these regulations maybe even start to come in place that actually require it, and then you could actually see recalls later on as a result of that. But even trace amounts can end up in closed loop systems. I know that's one of the things you help people address, right, Murphy?
Yeah, absolutely. And like I said, there's a lot of potential sources for it because benzene is sort of in the class of like volatile aromatic compounds. It's, the stable one. It's nice and, evenly structured to where, we've got a high boiling point, and most other more complex aromatics actually break down into benzene. And so, starting with the gas, we're essentially always fighting against potential contamination by benzene, among other things. And sometimes we introduce that benzene through degradation. Sometimes we introduce it through our environment. You can have up to 5 parts per billion of benzene in your drinking water. If that's conformant with standards based on what's safe for drinking water. So, trying to identify where a contamination comes from is really hard if you don't track it before the process ever starts, because there are many, many opportunities to bring it in. And you've got to be able to prove to yourself, to your process, and control for it as you go to make sure, because what you may end up with is 1 ppm from this area, 1 ppm from this area, 1 ppm from this area. And so if you ever get a test result at 5, you need to be able to demonstrate where those came from and follow it along the process. And when we're looking at, the source of benzene, like this is just a, naturally occurring compound that is in a lot of things, and it's present in a lot of places. So, most of the gasoline in your car, like there's benzene in gasoline is measured as a percentage point. We're not even ppms anymore. It's part of the volume, right? So, if you could imagine, having a gas station next to where you're manufacturing your gas, there's benzene in the air where people fuel up. One of the most common locations where people get benzene poisoning is the type of people who fuel up trucks and farm equipment, and situations where they're just exposed passively to gasoline vapors, even outdoors. So the limits are are really strict and really low because it's so abundant. So it's very dangerous and it's kind of everywhere. Great news, right? I'm sure bringing the vibe way up here. So, so my job trying to isolate it, one tank at a time is like, I'll never be done. We will never complete that task because every day you are opening yourself up to a new potential contamination. And so it is only by being vigilant and careful and documenting that effort that you have any hope of really actually eliminating it.
And the primary areas where we're measuring this are really in the supply chain, and then the extraction, and then the actual concentrate itself after it's produced. Is that right?
Exactly. And this is where the testing, originally was such a big issue because our cannabis labs have a lower limit of detection that's much higher than what an environmental testing lab that's trying to measure it in the air might be detecting for. The difference in the precision of the analytical equipment to give you a parts per million versus a parts per billion is sometimes a technology hurdle that we've only recently been able to overcome. Sometimes it's a cost issue. Sometimes it's a sampling error. And so it's, these are difficult scientific questions to solve for without the right amount of context. And so what you may have is a dilute, undetectable amount of benzene somewhere in the process that has to actually build up before we can even see it. And so the more places you test for this, the more likely you are to catch it at the location where it occurred. And hopefully that's before it ends up in your final product. Because again, this is a stable, heavy, high boiling point aromatic. So removing it is much harder than removing butane, getting some of these contaminants. And, we talk about benzene because it's the, some of the smallest limits and most toxic, but xylene is no good for you. Toluene is no good for you. And some really common sources for those is the vacuum pump exhaust in your lab. Any type of petroleum product, cigarette smoke is one of the most common sources for benzene because it's just a byproduct of burning stuff, so some of these are everywhere, and our job is to test it at each place where we can control it. I could test the air, but the air changes every minute. But if I test my tanks as they arrive and at critical points in my process, these are areas that we have control over and hope for being able to prevent rather than remediate.
Totally. And just throughout this webinar, we're going to refer to BTEX and benzene effectively interchangeably. They're separate things. Benzene or BTEX is a group of compounds that have kind of similar properties, but they're tested separately. But we'll just kind of use that interchangeably as we go. So some of the real world consequences, particularly recently, there's been kind of an uptick. I think especially noticed in California, there's been kind of a huge increase in the prevalence of batches failing due to benzene contamination. I don't know if you want to share some of that. Well, I've got a story that I'd like to share as well after.
Oh, yeah. If anyone would has experienced this themselves too, please throw it up in the chat if you're willing. But yeah, this is a problem that is kind of a side effect of increasing the scale of your production. And so we started seeing in areas where there's high volume processing, which often is paired with toll processing and just more complicated manufacturing logistics in the first place. But inherently, the more tanks of gas you buy, the more likely a concentrated effect. If we assume that there's 1 ppm per 100-pound tank, then it only takes refilling so many tanks before you've got some pretty big numbers. And if you're not controlling for that, there's just a very high risk of it showing up all at once one day. And because there's so many other variables, in a lot of cases, the only time it's being tested for and controlled for is in the final product. And so this has really hurt manufacturers in places like California, where you have third parties coming in to do the test sampling, and they're only sampling it after it's completely manufactured and packaged. So the most expensive time to not be able to sell it. And when those products go out for testing and they come back with that measured benzene content, the allowable action limit is like 1. It's any. It's the, the lower limit of detection, and then, the amount that they can see just over that. Usually our regulations are written to accommodate the test method, because our goal would be none, but there's no such thing as an analytical none. There's no 0 in that regard. So, when it shows up, a lot of times this product is just now done. And your ability to remediate that is relatively low if you don't know where it came from. Because a lot of the ways we would try to remediate it, for example, would be to distill the product so that we can separate the volatiles that are evaporating at 80 compared to the cannabinoids that are going to, vaporize at 170. However, heating it up again could produce more benzene in the process, because we could now have degradation and exposure and other issues. And so we end up with this really complex issue where in most cases people were left with product they couldn't sell, no explanation for where that benzene came from, and a lot of internet posts stating, oh, it's that gas supplier, I got bad tanks from them one time. And so then they just jump ship, they call a new supplier, they think a different color tank is going to be the solution. And, without any traceability and without any true batch tracking on just what tanks went in to what batches, in most cases, people who've had bad solvent issues can't actually ever point back to which tank when and how it happened. All they know is that bad things did happen, and they made as many changes as they could to get around it. And so, I had previously talked about this being a California issue, and I immediately got a whole bunch of messages about, no, this is all over Michigan too. And what I remember about the first time we heard about it from California is that there was a rumor that it was Canadian gas. And, I've got a little more tolerance for my Canadian neighbors than maybe most Americans. However, I just rejected this assumption of it being, oh, just Canadian gas. However, then I found out that it's the year 2025 and Canada's not testing for benzene. So maybe there could have been worse gas in Canada than in Washington or Oregon over the border, because Washington and Oregon are testing for benzene. And so, what we have is this oil and gas supply chain that goes international wherever they want. And we have this localized cannabis issue, and everyone is just stuck holding the bag, not necessarily talking to each other. And so the people in California who had an issue don't know if it's the same gas that the people who in Michigan had an issue. And those two people could be buying from different suppliers, but getting the same source gas from the same problematic manufacturer further upstream. It's a huge traceability issue. It's just a data problem. And it's one that we can overcome, but it requires participation from the oil and gas part of the supply chain, And that's hard when we're small for them, If they don't care about extraction too, then, our problems are small potatoes to them.
Well, no, and there is definitely vendors that are in conformance with the ASTM standards, right? And so it's really about, I think, the extract producers, first of all, being aware of what conformance looks like, how to actually hold people and their vendors accountable to that conformance, and how to check. And I think that's really what we're trying to accomplish in this webinar here. Is that's the takeaway we want you guys to take to come away with. But I can also share just not long ago, actually, a shipment that we had of our gas coming up the West Coast was put on hold and actually had to get recalled to the filling plant because it tested hot for benzene. And this is something that can happen upstream in the supply chain and never make its way to a customer, and customers never find out about it because it's not a recall that actually affects customers. Customers in our case being the actual extract producers. But when you're testing for this stuff, it comes up. You're going to find benzene when you test for it. If you don't test for it, you are not going to find it. And so it's quite convenient also to not test for it. because it's very inconvenient to find it and have to deal with all of the, the costs associated with that. But that's really what you want your vendor to have to do, is to actually have that happening upstream of you, and for you to never hear about it is the best case scenario, right? Because it's being caught before it ever gets to you, if you're a producer or an extractor. But yeah, I think a lot of times too is that people just aren't aware that how prevalent it is. And like you mentioned, that it's there's kind of whispers, and there's not really a lot of incentive for people to come out and talk about it and say, hey, oh yeah, we had a batch that was contaminated by benzene and we had to do a recall. Maybe it never made its way to their customers either, because it got caught before, at a point at which it could be prevented from being sold, but it was extremely costly. It's kind of embarrassing, and so because that word doesn't really travel, then people aren't really aware of the risk, and how prevalent the risk is. And I think part of this, and part of what actually a quality person's job is to identify, not just what are the risks, but how high of a risk it is. Like how high of a likelihood is it of happening? And if it does happen, what is the consequences of it happen? That's kind of a risk analysis that has to happen, right? So without that kind of information, it's going to be really hard for quality people to do their job and to ensure that they're actually protecting their companies from the risks.
Yeah, and I just want to point out too that the recall that you're talking about is very different from a recall that I might be talking about, in terms of maybe some vape pens go out and it's determined that they have benzene in them after they've been sold. That's a recall that's
Yep.
mandated by someone
Yep.
with authority having jurisdiction over my license. I don't get to decide if I want to call those back in or not. But in your case, there is no one in charge of you that would force you to send those cylinders back if you wanted to sell them anyway. And so if Phil
Exactly.
was like, I promised these guys I would get them 6 tanks on Monday, and now I won't have tanks till Wednesday because of this not my fault, optional send back. That's a decision you guys had to make on purpose to care a little bit extra, because that is voluntary. The only people who can hold you accountable are the people on this webinar right now, because we know who you are and how to get in touch with you, and that this is a problem. But it is something that is mandated on us as product manufacturers, and optional for you guys as suppliers of industrial gases. So it is something that takes effort that you just have to choose to care about.
100%. 100%.
It's also worth asking, where does that recalled solvent go? The supplier is potentially incentivized to sell it to Joe Schmo, and it could potentially end up in your lab.
Yeah, we're a buyer that cares and that is not going to accept that shipment. Are there other vendors that are willing to accept that shipment? That's an open question. We don't have the answer to that. The likely answer is yes. Some vendors out there are likely to accept that shipment. Are they accepting it with the full context that we have of the what quality systems are actually required by our local jurisdiction, by the state that or that our customers operate, or the the regulator, like Health Canada in Canada? A lot of them aren't even really aware of any of that stuff, so they it's not really their main business. A lot of people are buying this stuff from welding supply shops, and welders don't care about benzene, and welders don't produce something that is consumed through inhalation. So it's just a completely different ballgame. So I think let's jump into what are the grades of gas. And this is one of the most interesting pieces, is just like this instrument grade, extraction grade, industrial grade, these terminologies get thrown around a lot. And you brought this up earlier, Murphy. And you actually educated me on this as well, is that they actually are completely meaningless, because there is nobody holding anybody to account for actually what it means to be instrument grade. You could put instrument grade on anything because there's no body, there's no standard until now, until the ASTM standard, but it doesn't actually identify specifically instrument grade. So all of these different grades are effectively meaningless when it comes to what is the purity of butane that we should allow into our lab that is going to be safe to use for human consumption and is going to be used for in a combustible product or in in an extraction process that produces something like that. So it's totally unregulated, but now we do kind of have a definition. I would probably say like ASTM standardized or something like that. ASTM conformant might be a good word for butane that kind of complies.
Yeah, they prefer conformance with the standards since it is, like I mentioned before, optional and voluntary. So everyone opts in to conforming with it. Compliance would indicate that it's required, which can be the case if you get your local government to include ASTM standards in the regulations. But otherwise, it is a conformance that we choose to participate in. And so you can conform with the standard by only purchasing solvent that is conformant with that standard, or you could be conformant with the standard as a supplier who only resells what's going to be conformant with that standard. But it's all voluntary. So all we did was get most of the people who participated in the discussion to agree on minimum limits. And trust me, they wanted them lower, and we couldn't get testing methods standardized and agreed upon with all the scientists in the room on how to actually provide that for the industry. So right now, even as written, I would say that conformance with this standard is still allowing contaminants that are higher than most people who are involved in this conversation would ever want to see. This is just the limit of our standardized testing ability.
And that comes out to about 1 part per million, is that right?
Yeah, we've got, I want to say 50 parts per million is what we want to limit for specifically benzene, and then 1 ppm would be for the whole BTEX category, I believe. Someone check me on that.
Yeah, I'm pretty sure it's 1 ppm, so should be about 1 ppm and then less than a ppm for the rest of the benzene. But yeah, we'll have to double check that for sure. It is and then also the methodology used is a really important piece. So conforming to the ASTM standard for methodology, like if you have a test specification that is much higher, or the test methodology can only test up to, let's say, twice what the allowable limit is under the ASTM standard, you're going to get non-detectable under your testing limit. So you may actually get a COA, certificate of analysis, that says non-detectable for benzene, but it was actually, the actual content was twice what the ASTM standard would permit. So it's really important that kind of all of these pieces are in place. We've seen a lot of questionable, maybe even questionable ethics, I would say, with just presenting a conformity document or certificate of conformity as kind of like a substitute for a certificate of analysis. We'll talk a little bit about how to distinguish between the two of them. But a certificate of analysis is going to have the exact specifications that are kind of the limit that you're testing to. What were the results for this specific batch? How is it tested? What testing methodology? And there's a number of different ones depending on what you're testing for. And then all of this should be testing at the lot level. So there should be traceability to the lot that it was actually came from. And then there should be an additional level after the lot traceability. Lot traceability is typically at like a bulk quantity level. So it's being shipped to like a filling plant where the butane is being filled into cylinders. That bulk shipment is the lot testing, and then the actual cylinder testing should be done within the lot after filling. So then you're getting at least a sampling. Let's say there's 10 specific cylinders tested for a lot of 100 cylinders, and then you're able to get lot specific testing, at least a sample from that lot of cylinders, and you're able to see if potentially some of that has concentrated over time in some of the cylinders. Anything to add there?
Yeah, one thing I will add is, a lot of times, and this is something that, I've been relearning with every new gas manufacturer and supplier as we go, is that, they are in control of what they consider to be a new lot. And so, if you can think about the supply chain, it starts with like oil in the earth, and it comes out into some machinery and ends up on a truck. That's a lot. And then from that truck, it goes to another tank somewhere. Maybe it gets refined and purified. Maybe we got a sweet spot in the earth and it came out pretty clean. Literally, it's about that random, depending on where it's being pulled from, if it's a byproduct from another type of processing, but we're going from crude to trucks to tanks. And at each of those, changes in container, whoever's taking possession of it can then determine what is a lot. And when they make that decision, then follows all of the testing. So much like how we often don't want to run our process tank all the way down to 0 pounds before we come and refill again with a tank from outside, if you're topping off your tank, you had a lot in the process tank, you had a lot outside in the cage, now you have a new lot that's a combination of both. And further up the supply chain, there is a lot of that combination activity, because when the truck shows up, they're going to fill up their tanks. They're not going to have a bunch of half full tanks. They're going to batch everything based on what fits and where it goes. And then they're going to distribute that out into cylinders, and they're going to set a lot. So that lot could be based on what was in their big refill tank. It could be based on saying we always make our lot 50 cylinders. We always make our lot 10 cylinders. And all of those decisions are important because they impact how it's tested, when it's tested, and how representative that test is going to be. And so that's where I think, first of all, getting a COA sometimes is effort, but my goodness, you better ask for it. But then from there, that COA is only as good as the lot traceability. If I can't definitely verify that the tank in front of me contains gas from that lot, I just have a paper and a tank. I have no correlation between them. And so again, this is where, voluntary effort made by the people who are servicing this industry is the only way we're going to get it done. Everybody just has to be as demanding as me and complain as often and as loud as you need to. And Phil will answer your call and hear all about it. He's happy to, so, but it's through us asking for it and then checking. Because if you consider the complexity of this, there are so many reasons accidents could happen. A low detectability in a second lot with a just barely passing detection in a first lot, when they get combined, is no longer a sweet, even, ratio of the two. You may be creating new lots inadvertently in your own facility without realizing that you're crossing these lots together. And so, that COA only applies to you if you never mix lots together as well. We have to follow that all the way down. If you've got 2 process tanks in your facility, if you've got 2 different closed loops in your facility, there's a lot of opportunities for us to really just eliminate that traceability accidentally or inadvertently.
Well, and the best way to, at least at the supply chain level, is just the serialized tanks. So each tank should have a serial number, and those serial numbers should be included in the lot. And typically you can even get a list of every serial number of every tank that was in the lot, even though some of them, only some of them were sampled to actually produce the COA for the sampling. So just kind of in comparison to what you might see on something that you should look out for, certificate of conformance. We've seen a few of these circulating. There's no testing methodology listed. It might come from a giant gas supplier that may not be producing a lot of methane as a byproduct. But jokes aside, it's got no lot number or has no matching tank number to kind of pair up with your delivery. A lot of the times these don't have any results for benzene. So if you look on the right-hand table here, there's like, butane, water, sulfur, but for some reason they just kind of omits benzene. Well, if you don't test for it, you're not going to find it. And so you might actually find a very, very high percentage of N-butane. You might find that they're certifying that they're conformant to something like 99.9% or something that seems a little bit fishy high. Or even, even if it's above 99%, well, what are the other constituents of that? And they're not testing for everything that ASTM would require testing for. The other thing that, they may even test for BTEX, like I mentioned before, but the testing detection limits are so high that it just says non-detected. Well, you don't know what the specifications are. It doesn't say what their required specifications are and what the limits are that they're to their conformance. So if you don't have that information, you don't know whether maybe there could be 100 parts per million in there, and they actually just can't see 100 parts per million using whatever methodology that they're using, or 100 parts per million is within the range of their of conformity for them. And so without actually using the same standards across the board, you can't compare these things. You can't compare a certificate of conformance to a certificate of analysis that is conformant to the ASTM standard.
Yeah, and I think
So
the sketchiness of those, I think we're all kind of familiar with, because we've all kind of seen a cannabis COA from like, your gas station hemp products. Anytime the limit of detection or the upper limit of quantitation isn't listed on a COA, that's suspicious. Any lab who's doing a good job does have this information readily available, and anyone who's leaving it off the document is doing it for a reason, and I think it's common for us to discount the accuracy of the lab, but sometimes the accuracy of the lab is not based on the science being bad, but based on the intentions of the test being different for the person who is getting product tested and the person who's buying that product. So, these little nuances are no small feat. I was just about to post something for someone in the chat. We are actively in the current D37 group right now, trying to establish a standardized format to support this. And we need all of the help we can get from you guys to ask for what you want to see and ask us how you want to see it, because this is something we will only get by requesting it and by comparing it. Getting samples of different COAs has only proven that there's a huge gap in uniformity. So, from
and
one
transparency.
to the next. Yeah, and sometimes it's who you bought it from isn't transparent with you, and a distributor is one in a line, but often somebody somewhere made that decision. And so be as suspicious as you would if you got distillate with a handwritten potency note.
I think the other thing to note here too is like a lot of it is just to provide something as cheaply as possible. You have to omit as many steps as possible. You got to delete steps, and if testing is one of the steps, deleting it's going to save you a lot of money, especially if one of the things that you might find is also going to cost you a lot of money. That's not to say that benzene is actually in every single untested batch. In fact, I'd say it's probably still quite it may actually be rare. It may actually be 1 in 10 or less of the tanks that are that are going through kind of an untested supply chain that are actually going to come in hot, and that makes it even more difficult to assess if you're getting it from a supply that is not actually conforming to the ASTM standard in terms of their supply chain, you know, maybe people might think, oh, maybe we can kind of distill the gas and we can clean it up, or we can, you know, or we can do the testing ourselves and then we'll save money. And but yeah, ultimately you're going to have to test every single one, because even if you test a few of them and some of them are okay, it doesn't mean that you can rely on that to be free of contaminants every single time. And so yeah, because benzene's building up in, you know, in different places, particularly like the transport tanks and other parts of the supply chain, you just wouldn't know which tank is going to be the one that would kind of contaminate your whole lot of extract. So what to look for, on the other hand, obviously ASTM defines the purity standards. So listing the testing methodologies, accredited lab, or like a lot of them are doing their in-house testing because there's not a lot of labs. If you actually own a lab, or if you know a lab that is accredited to test for benzene in liquid butane, drop a comment in the question, because that's definitely something that would be useful information for the audience and for everybody in the call, because that's a kind of a gap right now. A lot of it really just exists within the distribution supply chain. It's good to have another third party that can actually validate. How do you know that your vendor is, you know, how do you validate that their validation is successful, and that their testing is successful? They may intend to have, you know, conformant test results, but then actually in the end, the only way to actually test and double check that is to have third-party testing. So that's something we definitely need in the industry. But you're also looking for lot and tank numbers matching your delivery, and that your actual tank numbers are listed on within the lot. And the tank numbers are in a serial number, so that's you can see that on your tanks that you get when you get your delivery. You may want to have some sort of internal systems as well for recording that. And so obviously you want to see that reported BTEX and benzene are under the contamination limits, but also that it's quantifiable, and the quantities are aligned with the standard. One thing that we offer as well is decontamination records. So one of the places that benzene can actually build up is in the transport tanks. They're getting constantly refilled, probably about 8 times a year is like the cycle. And so because benzene is slightly heavier than butane, you know, in terms of like its molecular weight, as the butane evaporates in the tank, and that's what creates the pressure to push the liquid out, it can actually concentrate in the tank. And almost all these tanks, especially the transport tanks, they have a dip tube. Well, the dip tube doesn't go right to the bottom of the tank. And so if the vendor is not at least occasionally cleaning these tanks and keeping records of the tank cleaning, then that little bit of butane can often just continue to concentrate and can be a source of contamination. So we offer cleaning records for every single tank, and we keep them on hand if you ever want to request them. If there's ever a non-conforming tank, then we can actually trace back, and we can like, well, was this tank cleaned? And then move up the supply chain from there and trace everything back.
Yeah, one thing I'd love to add on inspecting tanks too is I think a lot of us have, you know, received a delivery where one of the tanks, maybe often the tanks, but hopefully not, had a valve handle that was loose, or a valve handle that leaked a little bit because it was stripped when we put our fitting on. And one of the consequences of having an accumulation of benzene in a container, let's just say, let alone your product or your process, is that because it's a aromatic, you know, hydrocarbon, essentially, there's a lot of potential to degrade things. So you can actually break down the gaskets in the valves. You can actually break down the gaskets in your process tanks. And so, you know, when you encounter a valve that's a little bit wonky or suspicious, that is usually an indication of something having been in that tank that was no good at some period of time in the past. And so that contamination may not be relevant to the gas in the tank right then. However, if we have a handle that's leaking, if we have a handle that's hard to open or hard to close, we are now open to new contamination. Now we have to deal with air and moisture and whatever else is getting in. So, you know, if the tank itself looks bad, that's a really good reason to send it back. You know, if we all just say we're not taking tanks that are rusty on the top anymore, then they'll just have to stop sending them to us, you know? And the only reason to care about the outside appearance is if we complain, because the regulations and the mandates for refilling those is all about the inside being free of atmosphere and dry to protect the gas. But, you know, sometimes we see the results of prior contamination in just the way that you use it. So anytime that valve is suspicious, and anytime it's a valve that's different from the one you normally get, you know, if you have two different CGA adapters that you swap out based on who you get your tank from, that lack of standardization is going to very likely lead to more problems downstream. Because if there's benzene in that tank, it can erode all kinds of other fittings within that process that are normally safe. So even if it's not in there today, past presence can still show up.
So I think we've chatted about this a little bit, but just generally the sources. So like dirty tanks, cross-contamination from hoses is one thing that we haven't mentioned. But if anything in the supply chain is not specifically designed for this particular type of butane, that is like, you know, a controlled supply chain all the way back to the production process, then those hoses and fittings can potentially be a source of contamination. I think that's kind of what you're mentioning there with the valves. Accumulation we've discussed already. And yeah, I think the biggest concern and the biggest risk to me is just a lack of awareness, and that false sense of security can lead to decisions that, because people aren't aware of the risk, then they actually aren't taking any precautions, and that's kind of like, I would say, the biggest risk. But yeah, laboratory blind spots are another issue as well. But yeah, the limits are, I think we can confirm the limits are under 1 part per million for benzene. But yeah, one of the things I just wanted to showcase is this is a bit of an old video. We're kind of upgraded to a little more of an industrial process now, but every tank goes through a cleaning process. This is how we ensure that there's no cross-contamination. Especially one of the things, actually a potential source of contamination that we didn't list here is sometimes extractors will actually feed their butane from their extractor back into a tank. Back into one of the transport tanks. And this is actually a lot more common than a lot of extractors realize, because what happens is, like, if you have butane in your extractor and you need to clean it, you need to decommission it for whatever reason, they don't have an extra tank. So they feed it back into the transport dip tube tank. And so there's even potential for it to concentrate in the extractor, and then for an extractor to push that back into the transport tank that their vendor got, and then that goes back into the supply chain and goes back to the filling plant, but now it's been contaminated at the actual extraction site. So that's one of the things to look out for. But that's one of the reasons why we feel it's very important. This is actually not part of the ASTM standard. It's not required to do this cleaning, but I think it is a good extra mitigating factor to actually prevent any cross-contamination of benzene, but also even like anything that was in that extractor, if somebody were to push it back into a transport tank. And we've seen all sorts of stuff in there, like, you know,
Yeah.
just
And that
really,
happens
really
in the
low quality
winter.
crude.
That happens in the winter more often because your internal process tanks are inside the building where it's warm, and your refill tanks are outside where it's cold. So if you bring in a butane tank that's been outside in Ontario overnight in December, it is lower pressure than your process tank probably, which means that at any point in time, even if, let's say, you let your tanks fill up until it's full and then the pressure of the tank pushes back, that little bit of pushback, you know, like I was saying before, what you had at one point was a lot number over here and a lot number over here. And then because of this hose, Now we have a new lot number in both, which, you know, is a traceability that we'll only get by carefully paying attention as we go. And so the way you approach your transfill process, definitely never go straight to your tank, ever, ever, ever. And certainly don't go back into those transport tanks. If you're, you know, if you're decommissioning something for a while, the gas should never come back out of those transport tanks and into your process. And it's just as easy to burn it off. You know, you can get a patio heater, have yourself a barbecue, whatever you want. But, you know, burn it off and destroy it rather than take that risk, and rather than put it back in a tank, because that risk could come back to you in a future refill. It could come back to your neighbor in a future refill. And then everyone trying their hardest still won't get it done.
So are you saying maybe even get one of those, you know, like a regular propane tank for a barbecue that's empty, and then just push
Yeah.
it into that, and then just burn it in a barbecue?
Yeah, for sure. Maybe we get Lyndon on this and we have him build a cheap storage tank with the barbecue burner right on it, you know, with a handle. I've got like a portable one that's for like melting ice, and that's a delight. I love melting ice with my bad gas, you know. Smells like
I think an evolved
weed, and
flamethrower
it's fun to do.
could be in order.
Yeah. Okay. Solved. Get a standard for that.
Yeah, that might take a minute to standardize that. Natasha was asking, to help prevent this getting into our product, would it be good to add the butane into our collection pot first to purify the butane? That is one way to actually distill it. I think probably a better way is to actually have a completely separate device that is obviously pressure rated and has heat, the ability to deliver heat to it. You don't need a lot of heat, but really even just like a column is typically what we'll use, and you just fill that column, you know, bottom feed that column. You can do it with a regulator too. So one of the things actually we have in our genome system is it's just a heated column that has like a gradual flow going into it. And so there's always a little bit of butane that is vaporizing in there and boiling off back into the system. And what that allows for is us to run, you just turn that on when you're running, and then throughout the day, it just refills your collection tank, because every time you take a sock out, you're losing a little bit of butane. So you're just kind of trickling it in throughout the day, and it just hooks up to the condenser on our genome system. So that is kind of one little thing that really anybody can implement. That we can help you with that. But that's really a better way to do it than the collection vessel, because, you know, if there is any sort of benzene contamination and you put it into your collection vessel, then you're actually contaminating your collection vessel.
Yeah, and this is a problem as old as time. You know, the mystery oil started in the 5x refined, and then we got 7x, and it's 10x, and it's 12x, and we never saw an end to the mystery oil. And so I think a lot of people think when they're putting it into their collection vessel that whatever stuff they squirt out at the end is where the contamination is. But the contamination would be all over the entire internal surface of that vessel. So if you've got sight glasses on the top, you've got to take those off, clean and swap out those gaskets. You know, like that contamination is everywhere, not just at the bottom where you might see it. And so a lot of people think they're distilling their gas, but it's kind of like if you were distilling your oil and the distillate you wanted went back into the boiling flask. Like, you don't ever want final products to touch the same place where that incoming gas came. And the most important thing about distilling the gas is to introduce it to your system in a vapor form. If you are ever filling any part of your extractor with the liquid, you are creating a contamination point. And if you're gonna create a contamination point, it'd be great if it was like a 2-inch jacketed column on another skid that didn't matter, you know, and not something that was ever going to touch your product. Because for you to properly clean every internal surface and make sure every gasket is safe from contamination after a distillation would not save you any time. So even though normally I'm here to say increase your recovery speeds, this is one situation where you actually want to recover as slowly as you can tolerate, so that you can come in complete vapor form and make sure that you're not introducing that liquid solvent ever to anywhere that your final product is going to be until after it's been filtered.
Awesome.
The moral of the story is distill your gas.
But like for reals,
Yeah, I
not just fill it and call it distilling your gas.
Yeah.
think that's part of the equation. Everyone should definitely be distilling your gas, but I don't think you can just distill your gas and call it a day. Like
No,
there's more to
that's
it to
after you
prevent
checked.
contamination.
Yeah,
Yeah, that's after
absolutely.
you've done everything upstream in the supply chain. You've ensured as much as you can that you're not distilling contaminated gas. If you've done everything possible to ensure that, then distilling it is kind of a final measure. But I think we've kind of discussed a lot of this here in terms of ASTM standards and verification. Finally, yeah, the QAPs. So hazard identification, what is like really a lot of this comes down to a quality person's job or a QAP. It's their responsibility to identify this hazard first. Now that everyone here has identified this hazard, a lot of the time, then the when I have conversations with quality people, the next conversation is, okay, well, now that we've identified this hazard, what do I really need to do? Preventative control plan is the answer. You want to be able to actually put measures and SOPs in place in your quality system to prevent contamination in the extract and to catch it if it does happen. So that would include risk analysis, really identifying the severity and the likelihood of this happening, which we've talked about a little bit. Preventative controls, including cleaning. I know, Murphy, you've got some very specific kind of cleaning recommendations as well that can help quality people.
Yeah, I think, what I find interesting about the situation we're in is that, in the States, we've got a lot of people who are being tested for benzene, but we don't have any GPP or GMP. We don't have any quality people who are individually held accountable. And so the accountability is kind of spread across the entire lab and measured at the end of the process after we're done. Whereas up in Canada, we've got one person who's holding the bag for the whole LP and no testing whatsoever. What if we could just get those two ideas together, huh? That sounds like a solution, because I think, and I'm sure it depends on the LP, but how often is an industrial hygienist trained QAP person, how often are they going to also be a hydrocarbon extraction expert? How often are they going to know if sometimes you do a mixed gas for crystallization and sometimes you don't? Because fun fact, propane has way fewer contamination issues because of its increased volatility. It's easier to distill propane, so it is inherently more often a little bit purer. And so if you sometimes have a mixed gas or the ratios of those mixed gas change, will your QAP person know that? And how would that get communicated? A lot of times in the lab, the way that you identify your gas blend is off is by the pressure in the tank being low, or the pressure in the tank being high, or recovery taking too long. And so, those are context clues that are happening within the booth that aren't necessarily being documented and communicated backwards to quality control. And if they are, it might be in a monthly meeting where we are 10 tanks in the future from when that event happened. And so the communication that we have with each other is where the cleaning starts, because a lot of times what we have to do is build into our process an allowance for more cleaning than we think we'll need, and the ability to stop, shut down, and pause anytime there's a question. Because I can't tell you how often a contamination of any kind comes from when we got one more run. Our shift is almost up. This batch is almost over. How often do we just go get a tank, bring it in, top it off 20 pounds so we can get these next 4 socks out? And those are the moments where we're less likely to stop, pause, and assess the situation, and then it catches up to us afterwards. And so your cleaning protocols are important, but the timing at which they're implemented is really the difference between whether they'll be effective or not. Because when to clean is immediately after contamination, and immediately before processing material. And if that feels like all the time, that's correct. It's all the time.
Yeah, I guess actually one of the questions that I fielded before is a lot of people's cleaning SOPs are essentially just using using butane in a CIP
The same
process, clean in
gas. Yeah,
place.
yeah.
Yeah, exactly. So I don't know, can you speak to that? I mean, I think that it is possible to do it effectively that way, but I think there's, it's probably going to require disposing of that gas after the cleaning process.
Or having qualitative testing on site to verify. Because anytime you
Right.
use the same process solvent to do your clean in place, which would not be industry standard generally. Usually your CIP solution is a different solution. We don't clean a brewery with more beer. We and like truly that's silly, right? We call it clean in place, but what we mean is dry, like, a,
What I mean
a
is
solvent
easy to
only
do.
run. Yeah, we mean easy to do, exactly. And so, I stress this all the time that, most of the mess in our lab is water soluble. And so if you're never cleaning your system with water, you're missing a huge category of the potential contaminants. And while those might not be soluble in your solvent and make it over to your tank, they're definitely affecting your process. And you have no reason to believe that benzene isn't there too, because benzene's a degradation product of a whole bunch of other things that are in your cannabis. It's in your water at 5 parts per billion. So if there's water that you put into your cannabis plants and cannabis plants that you put into your closed loop, then I'll bet you've got the potential for crossover. That's why I love when the solventless guys say, oh, this is why you shouldn't use gas. Guess what, guys? Benzene's in water. So, the way that you have to approach this is by cleaning for everything else, because it's a process of elimination. I love to use steam for cleaning, especially on the material side of the system. And then you've got to dry it out completely, which you can do with nitrogen, you could do with heat, you could do with vacuum, a combination of all three. But regularly incorporating that deep cleaning, I think, is a critical component. And a lot of times it just comes from scheduling. Sometimes from the top down, they're going to say, we need to get these batches out. And what we have to say is, for every 5 that we run, 1 is true cleaning, or for every 8 that we run, or whatever your, tolerance for risk actually would be. And then from there, if you need additional cleaning, bringing in something like ethanol is going to help get the rest of the oil. I think that's also extremely helpful for anyone who's doing crystallization, especially if there are components of your process that are not jacketed, because that little bit of THCA may never quite fully dissolve in your same old process gas if those components aren't actually jacketed and actively heated. It's really hard to heat butane and move it at the same time unless the container it's moving through is heated. And so just running that CIP won't even necessarily redissolve cannabinoids if you can't get it hot. So anytime you're cleaning your system, it's got to be frost free, which means you're going to have to defrost those tanks every so often, guys. So your internal process has got to be informed by some regularity and then maintained. And it's really got to include some nice hot water, maybe a secondary solvent, if not a heated long-term soak, not run through, of butane if you insist. And propane is terrible for cleaning, so don't do that.
And I think the validation should also test for benzene, right? Some sort of a swab or some way to validate that your cleaning methodology is cleaning for the contaminants, but also, like you mentioned, getting rid of any THC from previous batches as well. All right, well, that kind of wraps up. Oh yeah, I guess the one last thing to mention on this actually is that we are going to be working on or kind of like a templated version of a hazard prevention control plan specifically for this little niche within our industry. I think it would be a really great resource for quality people who a lot of the time are a little bit under-resourced and just they don't have the awareness of what to look out for, and potentially not a lot of experience specifically in cannabis. A lot of them come from other industries. So we want to provide that as a resource to the rest of the industry. We're going to be working with one of the associations in the cannabis space to that organizes quality assurance people, and with their help, we'll be able to provide some resources to quality people so that they can be informed, and along with this webinar, have some kind of subsequent things to implement. I think it would be a waste of resources for every quality person or every extraction team in the industry to go and develop their own hazard control plans independently, because each one of them could take 50, 60 hours or something like that. So 300 companies spending 50, 60 hours is a huge amount of resources collectively. So I think it's we want to provide that as just an extra something that we're doing for the community to streamline things a little bit, help everybody get into kind of a synchronized conformity to the standards.
Yeah, if you're,
I think that's pretty much it.
well, I was just going to say, if you're interested in learning more about that, I was just going to say, comment no BTEX in the comments, and we'll send you some information.
Cool, awesome. Yeah, if there's any other questions that you guys have for us, we can address them. If there's any ones that we missed, I know that there's been a few questions dropped in the questions box here, but if we didn't cover it, then now's a good time to touch on it.
There
So
was
drop
one
any
question that
questions.
came up about in ice water hash. Is there a potential contamination risk there? But I think you covered that.
Yeah, water is drinking water that is safe for human consumption is allowed to have 5 parts per billion, and so it's going to show up and stick around longer in something that has not been distilled. So for your solventless, distilled water is going to be a safer bet than potentially filtered water like RO, because the difference in boiling point between water and benzene is a little bit closer. They're like 20 degrees apart. It's not as far apart as butane, but so something that's distilled is likely to be of higher purity, but trace amounts are likely. So what you're going to want to do is control that input, check that water, check your TDS, check for everything else, because you know that you probably have 5 parts per billion of benzene in the water just because. And so our tolerance for anything else is quite low,
One other thing actually is I think it would be good to share the actual ASTM standard. There's a link to it. We want to support ASTM and the work that they're doing and stuff like that. So it costs about $70 to download it, something like that. But it's a super good investment. We'll make sure we share that after. There'll be an email that goes out to everybody that attended. We'll make sure that a link to that is on there. But do recommend buying that. I think it's a small business expense, but a very good investment.
And it's free if you join ASTM as a participating member. And if you join as a participating member, it means you can sit in on all these work groups and just have an opinion. You can pay a little bit more if you want to be able to vote on the topics. But even just to be able to sit in on these meetings, know what we're talking about, and, hear behind the scenes from the guys who have the big trucks and the big tanks before it gets all the way to the refill cylinders, I think is worth it. I want to say it's like maybe $150 to join as a member, and then all the standards are included in your membership.
Cool. Well, I think we can end on that now. I'm not sure. Is there any more questions?
There is one more question that just came in. Do you think third-party testing lab equipment can become contaminated and be a source of benzene? For instance, they tested another lab product that had benzene, and now they tested your product, and your product tests hot for benzene.
Yeah, that is not really how analytical equipment works. Residue in analytical equipment prevents the analysis from taking place, and that's especially true in something like gas chromatography, where the process of testing it is to literally burn it into nothingness. And so the residue, if there was residue, would prevent the next sample from being able to be analyzed. So if that happens, that's happening to them, and they're having to rerun your sample multiple times, which is why they ask for the quantities that they do. But you're not going to get a COA that had that residual issue because it would not have produced data, because that measurement won't work if there's that residue, because that residue won't be residue of benzene in its original format. It'll be burnt, crusty residue of not benzene anymore, whatever it turns, just carbon, I guess. And so that residue is very unlikely to come from the analytical process, but it is highly possible for that to come from the sampling procedures used to transport samples for testing.
Awesome. Cool. Well, I think that wraps it up. I don't know if there's any more questions. Thanks everybody for attending. We'll be following up with a few emails, and we'll probably do this one again once we have made a little bit more progress on some of the quality assurance documents that we're producing. We'll have some time to share that with everybody.
Yeah.
Thanks for
and
attending.
If any of you love
we'll talk to you
gas
soon.
chromatography testing, get at us. We need more resources.
Exactly. Totally. Thanks, guys.
Thanks, guys.
Ciao.
Have a good weekend, everyone. Cheers.